Welcome everyone to this week's IPLD's weekly sync meeting. It's July the 6th, 2020. And as every week, we go over the stuff that we've worked on and we'll work on next week and then discuss open issues or answer questions. So feel free to join. And yeah, I started with myself. So I was on vacations for 2 weeks, so I don't have any work to report. Well, before my vacations, I worked a bit on Rust IPLD stuff and Rust multi-format stuff. And next is just catching up with the stuff I missed and probably quite a bit of Filecoin work. So I'm not sure if I will do much IPLD work this week, but I will surely catch up. So expect me to do code reviews and yeah, be visible in questions. But development wise, I probably do mostly Filecoin stuff. Then next on my list is Peter.
Sorry, lost my window. Yes, so as far as IPLD things go, everything I did was basically tangential. While trying to figure out how to test our Dumbo drop offline deal flow, at the end I basically ended up becoming a miner. Apparently Lotus is harder to keep up as a daemon than I originally thought it will be. So third time is a charm. Going to another setup right now, and hopefully we will have a full offline deal flow end-to-end with multiple nodes, and we'll be able to issue the queries with the selectors and stuff like that to actually check that everything works as advertised. On the Dagger front, I met with Michael and Rad to kind of reintroduce them to what is that we're doing with this set of tools. A lot of alignment happened there because Michael wasn't actually aware which direction this tool went, and we are going to figure out sometime this week what our next steps are. But step 0.5 seems to be that we'll see if we can cross-compile it either in parts or as a whole to Wasm and see how that will work, because everybody who Michael knows would be interested in this is very, very much in the Wasm realm. So that's that. And also had a long meeting with the person, I can never remember his name, I'm sorry, the person working on Rust UnixFS add command, and walk them through what are actually the components of adding something to IPFS, and which parts to basically do first take and which ones they can do later and things like that. It was actually a way longer discussion than I originally anticipated. And that's pretty much my week.
Cool. I see also updates from Chris.
Yeah, so last week was mainly just kind of digging in the Dumbo drop code and doing a lot of refactoring. So some of the key highlights are create a Visual Studio Code remote containers configuration, which if you haven't played that before, it's kind of cool because you can kind of encapsulate your whole tool chain and dependencies in a Docker container and then just basically spin that up. So it helps people get started really quick as opposed to figure out version conflicts or if they have the dependencies. Smoke test to basically run it real quick to make sure I didn't break anything, and 68 unit tests that run under 20 milliseconds. So that's really nice to make sure I don't break anything, and lots of source code documentation. So that was mainly around there's mainly, I guess, 3 phases. The first one is the most involved from the project point of view, where it does parses files and converts them into IPLD blocks, and that's pretty in pretty good shape. And I'm working on the second part right now, which is creating car parts, and it's much simpler, but I'm kind of having a hard time making unit tests run it because of the getting things to inject properly is kind of hard. And one question for Rod, there's a dependency on JS data store car, and it was on a branch called complete graph, which isn't there anymore, but there's an RVAG.
Got merged.
What's that?
It got merged, and it's in NPM as just data store car. So just install the latest data store car, and
Awesome.
it should work. That branch was merged, a little bit changed, but that should work as it is. Yeah.
Okay, that was my question. That's my update.
Thanks. Next on my list is Eric.
Oh no, I'm almost done typing.
Almost.
Yes, yes. So one small piece of news is that there is now a v0.5 tag of Go IPLD prime, and it just does some API changes, gets them out of the way. I warned about this last week, and now it's done, push, tagged. Those should be easy to absorb for anyone who needs to do so. The big news that I've got this week is we have CodeGen for unions, and that is really exciting to me. That was one of the parts of the implementation progress table that had a bunch of, well, no's in it, and now it's got at least a couple of nice green check marks. So this is kind of a big deal because unions, despite possibly sounding simple, have generally turned out to be one of the trickiest parts of CodeGen and the schema system, and especially to implement, because they involve making so many choices based on what data they expect to be within them. They're actually a lot harder to deal with than anything else like structs. In a struct, you know you're going to have all of these things, and that's simple enough. In the case of a union, you're going to have one of these different things, and you're going to need to branch wildly based on which one it is. And so they turn out to have a lot more code than you would maybe naively expect. So so far, there's only one representation mode implemented, and that's keyed, because that was also the easiest to do by far and will be the most performant. But we've got the keyed representation and the type level semantics both implemented now. And so that will get us pretty far, and just like proves out that the core design around them works coherently, which is just a huge relief. So this gets us really close to the point of being able to do a bunch of like cool practical things. I've basically not written a schema to date that doesn't have at least one union in it. So now that we finally got this, it's like, oh, yes. We can almost even self-host the schema. Almost. The one big caveat there is that I used inline union representations in the schema. And so I'm actually thinking about changing the schema to back that out and switch them over to keyed unions, because keyed unions are just better anyway. And it would happen to make this self-hosting thing a lot easier. So maybe. I haven't taken action on that yet, but like, probably. Yeah, so that's exciting. I've had a couple conversations with Rod about docs. I think we just need to carry those further, harder, better, faster, stronger. And in the future, I'm just going to be doing more. I'm so close to getting schema, self-hosting CodeGen that I kind of want to get that across the finish line in the next however long it takes. The next fun thing that I have in there is, it turns out that all of the placeholder type information structs that I've written just to like bootstrap the thing before I have the self-hosting loop, they can't be created with cyclic type references at the moment. So I have to deal with that and fix the placeholders at least one time before I can get the placeholders completely replaced. Oh well. some other fun details like that in my future, but I will not bore the meeting with them.
Does your experience with inline unions and your change of heart with the schema suggest that we should consider revisiting some docs about inline? I think we might have downplayed them, just saying that they're harder to discriminate, but maybe we need to put some more clarity in there about how this is one of the least ideals or the lesser ideal union types.
Yeah, I would really like to clarify that as much as we possibly can in the docs. It's a feature that we need because people make data like that, and there's enough of it in the wild that we care about describing it accurately. But yeah, the more I get into it, the more I'm just aware of how massive the performance implications are of these decisions too. Like keyed unions are just, I think I've said this in text in enough places, but for anyone who's watching and hasn't heard this rant yet, with a keyed union, the representation is you've got the map key, and that's your discriminant thing, and then the value. And the lovely thing about this X and then Y is the choice is made in the first part, and then you have the information to know what to do at the second part. Wildly enough, this means you can do it like efficiently. You know what the choice is. And some of these other representations, inline especially, is really nasty. You don't necessarily know that your discriminating information hint is going to come at the front of this range of data. So if it comes somewhere way at the back here, you have to buffer this data that you don't have the power to decide what to do with yet. And so your options for doing anything efficient there is like, nah. And so while I want us to be able to support reasoning about that kind of data, it would be great to encourage people to not do it.
Yeah, there's a bunch of stuff in the schemas that exist to describe data that we know exists in the wild, but then there's ideal data that would work really well with just schemas. But the schemas describing something that is more ideal than what there is a lot in the wild. So making that differentiation clear in the docs to say, hey, these schemas should be able to describe 90% of common data formats that are out there, or data layouts, but you should restrict yourself even further if you're going to design one from scratch using this stuff.
Yeah, we should make like a high level, we should make a meta doc about that somewhere and link to it all over the place from the details of the schema docs. It's a good idea.
And this discussion is actually continued in the issue that you opened last week about a new proposed union format you called it KeySniff, which may or may not be a reasonable name, but it's a good placeholder for now. But there's an issue called, about this KeySniff union type that would expand that 90% to maybe 95 to describe more types of data in the wild, but it does have all those problems of inline unions that make it less than ideal. But unions are this area where they're trying to capture this area in data, which it's where the sloppiness is in a lot of data formats that exist in the wild. And the more we can capture of that within the safe bounds of schemas, I think the better. But it does open us up to that sloppiness a lot more. So we have to be very careful, we have to tread very carefully.
Off the top of your head, can you give an example of data that's out there that requires the inline union stuff?
Well, here's the thing with it depends on who's designing the data. So if you
examples that are already designed is what I mean.
I can't think of one on the top of my head, but I would say if you went looking around in the data that's thrown around by people that write JavaScript, you will find a lot more examples of this kind of looseness with, this field may have this thing or it may have this thing. It depends on how I feel. No, it depends on what I'm trying to communicate, and I can deal with that flexibility because when I deserialize it, I've got this object that I can then manipulate in memory. Whereas people who do type languages need to prepare ahead of time and say, when I deserialize it, I need to really know what's in there. So yeah, I can't think of one off the top of my head, but you're much more likely to find those kinds of examples in the untyped ecosystem, where we can just throw around these objects and then deserialize them into these formats and then make decisions in code much more easily.
Okay. I guess I'm asking this because like we are talking specifically about kind of like persistence or storage formats, which normally people do not do the NoSQL stuff in storage formats. And that's why I was like, do we actually have an example of that? But yeah, because interchange, yes, I get that. But yeah, anyway.
Yeah, I've kind of just made these choices off of my collective vague recollection of every JSON structure I've ever seen in any API ever, undifferentiatedly.
Exactly, and those are APIs, right? Those are transports. Normally, nobody stores JSON on disk. I mean, okay, you know what I mean? Like nobody, yeah.
I want these tools to work for that stuff too. Like I've got some developments I want to do that have that kind of web API thing, and there's no reason that I shouldn't use IPLD schemas to be absolutely freaking awesome at that.
Oh boy. Yeah, I think that's a bridge too far, but
nope. Doing it.
I'll be right behind you.
Well, there's inline unions also have this potential, I think, to act in a space where you could have a complex structure that's got a lot of optional things in it, or you could discriminate into two types of structures. So it does exist in this space where you have optionality with how you write your schema. So, like, and that's because they're the examples I can think of. Like, you know, I reach for things like the NPM data, which has got so much optionality in it. So when you describe a package, some fields may be there and some may not, depending on how the author has done those packages. And it's in those examples where you could say, you know, I've got fields and optional, optional, optional. Or perhaps there's a mode where I receive the data where I've only got 3 fields and all those optionals disappear. So maybe then I discriminate that with a union and say, well, if I've only got those 3 fields, then, you know, it's a this thing. And then if I've got these other fields, then it's a this thing. So that's where that sloppy space that inline and this key sniff would exist.
Understood. Yeah, good point. Thanks for going into that.
And if anyone listening is interested more in this stuff, there is in the schema's specs, which is on the specs.ipld.io website. We do have examples of inline unions and the other union types if you want to learn more about it.
All right, next one on my list is Rod.
Yeah, so mine was another week of lots of little things, which at the end of the week I come to and I go, what have I done? What have I achieved? But I did manage to do an accounting of lots of these little things, so it doesn't seem as bad as it did in my head when I first started thinking about what I've done. So at the beginning of last week, I finished off the IPLD-ification of Zcash data and got that it packed up into car files for Filecoin Discover. So it doesn't represent like today's Zcash blocks. It has to rewind a little bit because what I did, and I did the same thing with Bitcoin. I packed them up into 1 gig car files, and I didn't have a leftover car file. So wherever the last 1 gig took me to is where I stopped. But these things could potentially be added to as well later, so it can be run again. So it took me to about block 810,000, which is, I don't know, within the last 2 months, I think. And yeah, so that's all done and uploaded. The code is complete and works, and was much smoother than Bitcoin because Zcash have made some better choices with regard to versioning in their data format than Bitcoin has. And there seems to be a significantly less amount of people writing novel data than Bitcoin, which is maybe understandable. So there's fewer edge cases that are having to be caught. So once I got the basics in place, it ran pretty nicely. And that's really interesting in itself. Just the way that people have really been poking and prodding at Bitcoin to stretch the format to enable different mining types and to pack weird things into the transactions. And people just aren't doing that with Zcash because it's not as fun or it's not as profitable. So the code works fine. It's all good. I got a lot of code for this stuff and the Bitcoin work in pull requests that are not merged. And that's largely because of documentation, which is not fully complete. It's the code documentation for Bitcoin is complete. Code documentation for the Zcash stuff is not quite complete. And then the next item is related, which is doing the Bitcoin spec for the IPLD specs repo. I am still working on that, chipping away at it. It's a bit tedious and I keep on coming back to it. So I need to finish that up and then do the Zcash one as well. That's basically where all the, my brain dump about these formats as content addressed formats goes. So all the edge cases, how to think about it as content addressed, how to bridge the world of blockchains and cryptocurrencies with content addressed data structures, which needs a lot more bridging than you would think from a cursory look at the two things. So that's going on. I handed off some Filecoin Comp Lambda calculation work to Chris during the week, who's now got to have some fun figuring out how to make this stuff presentable for presenting to the world. That's all open source anyway. It's just not very pretty, and it also, that code overreached because it was trying to figure out how to do it and how to do it efficiently enough to run in Lambda. So there's a lot that can be trimmed back there, but also some docs. And also Filecoin proofs code has churned a lot since then, so it needs to be updated for the latest Filecoin proofs code. So Chris has got that. Helped Peter get the Filecoin CID stuff. I don't know if that got merged. That didn't get merged, did it, Peter?
No, not at all. But it is on their board for the next test net reset, which is in about 2 weeks. But basically, it's a massive change for them, just because for me it's they need to touch. So, but I basically got it on their board, so it will happen.
Good. Okay, let's not dwell on that one. That's unpleasant. Did a write-up yesterday about and this is something that is in an area that might be useful to have some sort of concept doc in our specs about. So we continue to face I think they're philosophical differences with the blockchain world when it comes to Filecoin. And it's the same stuff that I've encountered with Bitcoin in particular. But it's this content address versus blockchains for cryptocurrency thing. When you're building a blockchain and you are thinking about it from the perspective of a miner, you have a lot of things available to you for making decisions about your format and its changing and its ability to change over time. Most notably, you have the chain height, so you can make decisions based on what height you're at any point in time. So say you're at a height of some 100,000, and you say, okay, I want to switch out the way I'm storing these numbers. I want to start storing my floats as strings at height 100,000. You can do that, and all the miners, all these full nodes have that height information, but height is not something that's stored in the blocks. So if your format is branching based on height, then you need to be able to navigate all the way back to the Genesis block to make that decision when you're reading the format. And from our perspective, when we're viewing content address data, the more locality, the better. So when I encounter a content address block, I've got a hash and a thing of data. And you've got a multi-codec that says this is the type of data it is. It's nice to be able to say this is the type of data and I know how to read it. But if you then have to say, okay, I have this block, but I need the 100,000 blocks before I know how to read it. That's not ideal. And in the blockchain world, it's sort of reasonable for two reasons. One is that most software that is decoding these blocks has that information, and so they store height adjacent to the binary data. They have it, so it's not that big a deal. And also, there is this philosophical idea where the blockchain provides you security if you can validate it back to the Genesis block. So there's, and forward as well. So just having that ability to say this thing is connected to the Genesis block is part of the idea behind a blockchain. And so height is part of that. It's just locality makes everything else so much easier. And so trying to get these data versioning things into more localized tools is better. And so Zcash notably is using their version field. They've got version fields in their block headers, but also their transactions. So the units that are content addressed, they have a version field in it, and they're actually using that version field. They have two. They've got a version and a version group ID. But when you combine these two things, you get to, and they're right at the beginning of the binary format, and so you get to make those decisions locally. Okay, this is the version. This is the version a version group ID. I know how to decode the rest of it, and I know what it all means. Bitcoin has a version field, but it doesn't use it as well. And as far as I know, Filecoin doesn't really have version fields. So I did a bit of a write-up about that just to pass on to the Filecoin team. It's something we've talked about a couple of times before, but it's never been sticky.
They actually do have a version field in Filecoin, but it is at the Bitcoin level that is essentially undefined right now. It's like for future use. And when you don't define something, you know what you find in it after a while, right?
Yeah, that's right. Miners will use that.
Yeah, and I actually put in the document that you put together a reference to BIP9, which is supposedly a way how to reconcile a single version field with the ability to fork the chain and how to basically put this all together. So basically which soft fork will win at a specific height. And that is something that I'm not sure why, like Bitcoin defined it, I'm not sure why they didn't end up using it at the end. So either they have a flaw in it or they just never got consensus that we need to start with something like that. But TLDR is that for Filecoin, this might actually be a thing to consider because it is relatively well thought through from a read.
Okay, yeah.
There was one term of phrase that you used there that I thought was really interesting and good, that some version fields have been better used than others. And that so implicitly having a version field doesn't mean you've magically fixed it. It's how you plan to use it that matters as well. Yeah.
Yep. Especially if you, in these situations where you, as the author, don't control how this thing evolves over time. So you can't, with a blockchain, a cryptocurrency, you can't say, well, I know how this will evolve over time, because you have to reach consensus among your miners, and there's a good chance you're not going to be the one with the enough power to just make those decisions. So, this thing will evolve out of your hands. And I think that's really the story of Bitcoin, is that it's like, okay, we planned ahead of time, but this thing just has a life of its own, just due to the, in quotes, wisdom of crowds.
We'll put Git on the
wisdom
network.
Is questionable.
Yeah, we'll put Git on the network and we'll figure how to make merges later. How hard can it be?
Yeah. That would just be a wonderful process to watch. Okay. So that Anyway, that's going on in a Google Doc. I don't know if at some point maybe that'll come out as content in the specs repo. If anyone wants to see that, let me know. But otherwise, it's yeah.
I also really like that framing, for what it's worth, of the more locality, the better, and phrasing that as a continuum that you want to climb up is a really good way to phrase that.
Yeah, that I think that's how we think. But I don't know how to bridge that to the blockchain world because I know that's not how they think, and I think it's reasonable that that's not something they reach for. So the challenge is, how do we, as people who think at the block level, communicate that as something and as an ideal for people that are not thinking at the block level?
It's more like the cost of locality for us is somewhere there. It's abstracted away, but like right now, every time I need to sync a Lotus test node, this is 4 hours for testnet, which is like a week and a half old. So that's a lot of data.
Yeah, this is the point. Another point I made. I think so. My understanding is that the blockchain for Filecoin is going to be very thick, and so it's going to generate a lot of data and over time. And so with Bitcoin, it's going to be going for 11 years, and you've got around 300 gigs worth of data. Ethereum's around 300 gigs and they're younger. Filecoin could be bigger sooner if it's successful. And so the cost of being able to say, at height 100,000, you do this, increases as that height increases. And then you have to have all that data. You know, one day Bitcoin will have terabytes worth of data, and you know, disk is cheap, network will get cheap as well. It's not like this stuff is insurmountable, but there is a cost to having to say height. And so then you end up minimizing the trust that comes with blockchains, because as you see now with Bitcoin, there's not that many full nodes, and the number of full nodes have been reducing over time. And so you end up having to use these third parties. And so you go to a blockchain explorer, and you say, I want to understand what's in this block. And then you have to trust them that they're giving you the right information. At height 100,000, it's doing this. Okay, I'm trusting you that you know the height. And I'm also trusting you for all these other reasons, because I don't want to run a full node to understand that data. So this trust relationship breaks down as it becomes more impractical to have the whole thing. So the more you can verifiably say this is likely data from that blockchain, and this is not only likely, but this is certainly what the data says. So anyway, there's some really interesting philosophical stuff there that I hadn't, like we had this argument with Filecoin last year, but I hadn't really dived as deeply into the blockchain, these cryptocurrencies, until this year. And so there's some really interesting focal points for the work we're doing that is coming out of this. Anyway, moving on. I did some minor cleanup in the specs repos, a couple of PRs and issues that just moved on and closed, merged. As Eric mentioned, we discussed some near-term priorities for doc work in the specs repo. I want to take some of these gists that he throws out, full of these really good ideas, and turn them into more formal spec documents, if they're concepts or specs. And with that, I'm currently working on the one that he came up with last week, which was codec completeness, which builds on some work that's been mulling around for a little while about the spectrum of completeness for any IPLD codec. When considering that IPLD, it has an aim to be able to describe a large number of content addressed formats, from Git to Bitcoin, and then along that continuum of completeness towards things like DAG CBOR and DAG JSON, which are close to being able to fully describe our ideal state of somewhat arbitrarily shaped data, not just these specific formats. And so what does that spectrum look like, and what does it mean to move up towards the ideal, and what is the ideal? And so Eric captured that really well in his gist. I'm trying to turn that into a doc, but there will be some pivotal things where we have discussions around what does this ideal mean, particularly the thing about sorting maps, that we've stumbled on a couple of times together, that we need to stumble on properly and really get a shared understanding of what it means for things to be sorted and at what level and with what default, all that sort of stuff. That's really tricky actually, but it's good to get that out in this way, because the doc at the moment basically says there is an ideal end of the spectrum that we don't exist at yet. So we could push further, but it would mean defining our own format or changing the way we're using CBOR, for example. We could do that and push towards the ideal even further. But it might be that at that ideal end, you're just in a realm of compromises and you're just making the right compromise for your use case. And lastly, I'll be on family holiday from the end of this week and for next week, but I'll be just working with reduced output. I'm not planning on disappearing, but I probably won't show up to next week's meeting because I'd like to sleep in. So yeah, that's all.
Acceptable.
All right. Anything else anyone wants to discuss?
I want to know when Rad is planning to work on Dogecoin. When are we going to take the blockchain to the moon?
Extremely tempted to, because it would probably be really easy, and it's just a matter of how much bang for the buck that is. And so there's so many coins that would be really fun to throw out there, but yeah, probably not. But it probably wouldn't be hard because it's like an easy fork of Bitcoin. So I don't know if people would take us seriously if we had a Dogecoin codex spec in our repo.
Dude, we already carry all the crypto cats. I mean, come on.
It'd be like the TCPO carrier pigeon sort of RFC. Anyway.
I have one information for Chris. If you work on the CompP stuff and look also into the actual Rust fill proofs code, and you wonder why isn't this thing just a streaming operation, it could be. It's on my to-do list, but I haven't gotten into it. So just in case you wonder, like, why is it do things in memory or on disk or whatever, and you could just stream it, you can. So just, yeah, because like, yeah, I would expect this double across it, and then, yeah, what if there's a reason, there's no reason. There's even an issue
on that note, Valko, because I did describe all that to Chris, but there is this awkward bit where the CompP calculator has to re-implement the whole CompP generate function, because the Rust field proofs only allows using the Merkle tree algorithm with a specific storage, backing storage, cache storage, and we need memory storage, and there's no way with the Rust field proofs API to switch the storage. So you have to re-implement a whole function.
No, I think I fixed that one. I think.
I was looking at it the other day, and it's like all hardwired. The type it is in there, so that's awkward. But it just means re-implementing like 10 lines of code.
Yeah.
But it would be ideal not to have to re-implement it.
Yes, but like those changes, like those would be. I'm not sure if these days, but it should be fairly easy to get in if there's basically an easy way to do it in the Rust fill proofs code directly. Because as I said, I actually thought I did this already, but if I haven't, then yeah. We can
So Chris might ping you about that. So Chris, there you go.
Yeah.
Volker's the one to ping about all that stuff.
Okay,
Yeah.
great.
Cool. All right, then I think we're good. And then yeah, I close the meeting and see everyone in a week. Bye, everyone.